Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over 3D figures. We're going to first talk about a whole bunch of vocabulary and then look at naming shapes and determining how many faces, bases, edges, vertexes they have. And then we're also going to cut these shapes either horizontally or vertically and decide what shape do we see when we slice them a certain direction. So let's start out with the vocabulary up here. A face is simply a flat surface on the shape. So everything we are going to be dealing with are three-dimensional. So they are, actually I'm gonna leave some room here. So they are not going to just be a 2D shape on a piece of paper. You're going to be able to see behind it. It's going to be three-dimensional. So a flat surface is this face over here. Now, there are lateral faces and then there are also bases. We're going to talk about what a base is, but a base is also a face. So this here is what we call a lateral. Lateral meaning it's on this side. So this is a lateral face. Next one, a base. I'm going to change colors and keep these consistent. So a base is going to be the bottom of a solid. It's also how we name shapes. So the base is usually in the word of that shape. It's also, like I said, a base is also a face. So for example, over here, that lateral side, that rectangle is the face. Now here we see it is triangular, so this here is our base, and we call it a triangular prism. Not always is the shape sitting on the base. If you notice here, the base is on the side, so be careful. An edge is going to be, we're going to name these, they're basically lines, and this is where the faces meet. So lines where faces come together or meet. So for example, we are pointing right here, that front face that we pointed to, and then that back face, those are coming together at the edge there. And last one, a vertex, kind of similar where we said lines where the faces meet. Well, vertex or vertices are points, and that's where the edges meet. So for example, these red dots that I'm making, those are all vertices. So over here is pointing to a vertex. So there are our four definitions. Now we're actually going to label a figure, and then we're going to identify the number of faces, bases, vertices, and edges. So the shape we were just working with, up above, I said, is a triangular prism. So that's how we name this shape. Prisms always have rectangular sides, and then its base is how we identify it. So we could have a hexagonal prism, where then the bases are hexagons. Now here, our base is the triangles. So these two triangles are what we call the bases. And you could flip it around, they're going to be identical bases. So we have bases that we're going to name. There are two of those, and those are the triangles. All right, the faces. So we have then lateral faces, and that is the sides, those rectangles. These do not count the two triangles on the side. So we have a rectangle right here on the front. We have the bottom rectangle, and then we have this side rectangle over there. So there are three, and I don't want all those colors to confuse you. There are three lateral faces. So total faces, remember, bases are included, so there are total 5. 3 lateral, 2 bases. Edges, so the edges are these lines, so 1, 2, 3, but we also have them in the triangle, so 4, 5, 6, 7, 8, 9. There are 9 edges. And then vertices are, where those points are, so 1, 2, 3, 4, 5, 6 vertices. Okay, now think about cutting this shape. If we were to cut this shape, let's say, I'm gonna try and pick a different color here, horizontally. So we would cut this shape, and I'm gonna kind of go from the side here, horizontally down like that. So if we were to cut kind of the top of that shape, well, what would it be? It's gonna be what's parallel to that. So the bottom shape is a rectangle. So if we cut this, a horizontal cross section is what we call them, then the bottom shape would be a rectangle. So what would we see if we cut it that way? Now, if we cut it the other way, where we go vertical, so we would cut this way, a vertical, well, then you're going to see, again, what's parallel to that. What's parallel is this triangle base. So a vertical cross section would result in a triangle. And it's a little hard to see without actually physically cutting those, but cross sections are cutting a shape open. And then what shape is there when we cut them open? Okay, so let's go to the next one. Here we have a rectangular prism. So every face in this shape is a rectangle. So we call that a rectangular prism. You also may see this. Sometimes people call them cuboids. Instead of a cube is where all the sides are the same, but if they aren't, sometimes it's also called a cuboid. So the bases here, we're just going to assume it's sitting on its base. A rectangular prism, you could turn it many different directions, so it depends on kind of how you look at it. We're going to assume it's sitting on its base. So there are 2 bases, and those are rectangles. We're going to assume they're rectangles because it's not showing us that they're all the same face, that they're not squares. Okay, the lateral faces then are those 4 on the outsides of those, on the sides. So lateral faces, we have 4. So there are a total of 6 faces in a rectangular prism. Okay, now again, let's look at edges. So we have 1, 2, 3, 4 on the top, 5, 6, 7, 8 coming down to the bottom base, 9, 10, 11, 12. So there are 12 edges. And then vertices are all those points. So we have 4 on the top and we have 4 on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, all the points. Okay, again, let's think about cutting this shape, doing a cross section. So if we cut it horizontally, what is going to be shown? So a horizontal cross section, well, the parallel side would be either the top or the bottom, the bases, so we'd be showing a rectangle. Okay, now if we cut it vertically, okay, again, it would be its parallel side. So a vertical cross section would result in the rectangle on its side, a lateral side. So again, it would result in a rectangle. Okay, the thing about a rectangular prism is all of the faces are rectangles. So if we cut them vertically or horizontally, we're going to see a rectangle. Okay, now next side, we have a few more shapes that we're going to talk about. Here we have a cylinder. It is on its side. So in a cylinder, the base is always the circles. So the bases, we have 2 of them, and we call those circles for the base in a cylinder. And that always holds true. Now, the lateral face, in order to be a face, it has to be a flat surface. So the lateral face in a cylinder is that curved part around the outside there. Well, that is not considered a face because it's not flat. So there are 0 lateral faces, so the total faces in a cylinder is just those 2 bases, the 2 circles, okay? Edges are straight lines. So again, in this example, a cylinder doesn't have any straight lines. So there are 0 edges. Same thing with our vertices. There are no points because a cylinder is round. Spelling it wrong there. Vertices is also 0. Okay. Now, cross sections. If you were to cut the cylinder horizontally, think about what you will see. You're going to see a rectangle. Okay. Now, be careful, because right now our cylinder is laying down. If the cylinder was standing up and you did a cross section, well, a horizontal cross section, it would be different. Then you would see the circle. So be careful. Now, this example we have, if we do a vertical cross section, so cut it this way, well then its parallel side would be the circle. We would see a circle. Okay. Next one we have, so if the side lengths are rectangles, like in our first 2 example on the front side, those were called prisms. Notice now our sides in these next 2 examples, they are actually triangles. So if the lateral sides are triangles, then we call those pyramids. And again, we name them based on the bottom, the base shape. That base shape is a triangle, so we call this a triangular pyramid. Okay, now this next example, I'm going to jump down just to naming it. It does have triangular sides, so it's a pyramid, but the bottom is not a triangle, it's a rectangle. So we call this one a rectangular pyramid. So rectangular sides, lateral faces, that is a prism, and then triangular sides, that is a pyramid. So let's look at the total number of bases here. It is sitting on 1 triangle. And then the lateral faces are the sides. So there are 3 triangles on the sides there. So we have 1 in the front. We have, erase to show you. Then we have 1 back here. And then we also have 1 back here. So there are 3 lateral faces. So total faces, we have 4. Then edges. So edges, we are looking at those lines. We have 1, 2, 3, 4, 5, 6. We do not want to count them more than once. So edges are 6. Vertices are all of our points. So we have 1, 2, 3, 4. So that's for our triangular pyramid. Okay. Rectangular pyramid. So now our base, again, a pyramid will always have just 1 base because the sides are triangles and it comes together at the point. In this example, our base is a rectangle. Lateral faces, and I'm looking up above and notice that I spelled lateral wrong. I'm kind of going fast through these. So lateral faces are those 4 triangles on the side. We have 1, 2, and then we have 3 in the back, 1 on the side there. So there are 4. So total faces with the base and the lateral faces is 5. All right. Now, edges, again, don't count them more than once, so be careful. We have 1, 2, 3 on that left side, 4, 5 on the back, 6, 7 on the right side, and 8. So we have 8 edges. And vertices are our points. we have 1 at the top, and then we have 4 in each of those corners, so a total of 5. So there are 2 pyramids. Okay, last 2 shapes, we have a sphere and we have a cone. So a cone, think of like a party hat, a traffic cone. It is sitting on its base in this example. A cone, the base is always the circle. Okay, kind of like our cylinder, lateral faces, they have to be flat surfaces, and that rounded part does not count as a face. So the total faces is just 1, just the 1 circle base. Okay, edges, again, they have to be straight lines. That bottom connecting there is curved. Same with these edges here. So the edges is 0 because they have to be straight lines where 2 faces are coming together. Well, that doesn't fit our definition, those 2 sides there, because those aren't faces. So edges are 0, have to be where the faces come together. Vertices, there is 1 point here at the very tip where it connects. So there's 1 vertex, and I guess I should. Vertices is plural, so there's just 1 vertex. All right, and last one is a sphere. Think of a basketball, a bouncy ball, any sort of ball is a sphere. Base, it's all curved. A base and a face have to be flat, so there is no base. Lateral faces, also, none of them are flat, so 0. So the total number of faces, there are none in a sphere. It does not lay flat. Edges, again, they do not come together to form any straight lines. So 0 edges and 0 vertices. Okay, now those last 4 examples, I did not do the cross sections, but I do want you to think about cutting shapes different ways. Think of a loaf of bread. You could cut it vertically to get a slice of bread, or you could cut it horizontally, and you're going to get 2 different shapes cutting them that way. So think about cutting all of these shapes horizontally versus vertically, and then what shape would you see when you do that, okay? So that is our talk about 3D shapes, all the features to a 3D shape, and then cutting those shapes in certain directions.